Manufacturing sites and assembly plants reduce your energy costs by 10% guaranteed. And by guaranteed, I mean if you don't save at least 10%, you can get back every single penny that you paid for this video. Okay, let's go. Number one, install an energy management system. I don't mean some sort of clever piece of technology, I mean people. Yeah, appoint some energy champions, get them to meet regularly, give them the data they need and the reports that they're going to need to do their job, and then get them to think of ways to save energy. I know it sounds bonkers, but staff do care. People know their equipment, they know their machines better than other people. Put them together in a room, get them to meet regularly, make sure it's written down, circulated, and maybe it's a monthly meeting, maybe it's a quarterly meeting. That's my number one tip. Every site I've been in that has a management system like this in place has significantly lower energy use than others. Okay, so that's number one. And it probably doesn't cost you a penny. Bit of management time, but very cheap. Number two, fit yourself a smart meter. Okay, let me just play this video here for you. Get yourself a smart meter and you get output like this on the screen. Now, without fitting a smart meter, you can't see what's going on. So just make sure you've either got a smart meter fitted already and you can access the data, or secondly, get yourself one fitted and use the data. On the example here, notice that the energy use never goes below about 50 kilowatts. I'll just run that again for you. So it never goes below about 50 kilowatts. If you multiply that out, and we assume 22p per kilowatt hour, that sort of base load, the thing that is always there 24/7, yeah, it works out to be about £96,000 a year. If you can save half of that, that's a £48,000 a year saving right there. I have never ever seen this baseload analysis deliver less than say £10,000-20,000 worth of saving. So it's well worth doing, but you need a smart meter. Number three, even if you've got a smart meter, fit yourself some sub-meters so you can take a look at what's happening with your equipment. Okay, you have machines, they take power. Have a look at the profile of the power that they take by either a BMS or down there I put one of these clip-on meters that you can get as well. You want to look at whether they've got the correct dwell time, i.e., during operation, is it what you think it is? Yeah, and the time between operations is, the energy use during those times is as low as possible. Some complicated pieces of kit, you will not be able to fiddle with it or sort of tune it, shall we say, unless you have guidance from the manufacturer. So if it's an expensive piece of kit, get in contact with the manufacturer, get their help, okay? Fit yourself a BMS system or one of these clip-on metering systems, and then don't just look at the data for operational cycles. Have a look over months, track it, because that way you can spot wear and tear. And as you see the energy use per cycle going up and up and up, maybe that's some sort of clue that you've got some dodgy bearings somewhere, or the motor's sticking, or the pump's not as efficient as it used to be. Okay, so look at trends over time. So now, variable speed on pumps, fans and motors. Okay, you can do this in one of two ways. You can either drop the voltage, subtle hint, that's what's on the next slide, or you can fit one of these inverters on there, and they play around with the frequency and will reduce the speed down. Interestingly, if you drop the speed of a fan by 10%, you get roughly 30% energy saving. Okay, and many times I've seen them work just as well. It's not critical that you have the fan running flat out. 90% is absolutely fine. Okay, so have a look at variable speed drives. They're also called inverters, and see if they work for you. The next one is kind of related. It's a voltage reduction, and it does kind of the same thing, but instead of changing the frequency, it will change the actual voltage. Interesting to note that in the UK, certainly, we should be at 230 volts. I've seen 247 volts. I've seen as low as 220 something or other as well. And so the other thing that you get with the voltage reduction devices is sometimes they have limiters in, so that if you do get spikes coming down the line, they'll flatten the spikes. Okay? So, next, if you've got, I saved someone £500,000 once by doing this. There's a company I know had a conveyor belt, and it was absolutely end of life. So they were about to check it out. £500,000 for a new sort of conveyor system through the factory, And do you know what it was? It was one set of dodgy motors. And the way to spot the dodgy motors, one bit of the line, was duff and it affected the whole of the thing, was we got a thermographic camera on, scanned it down, and when you get bad bearings, bad motors, they show up, they glow white. So if you've got production lines moving stuff, get a thermographic scan in. It's not expensive. I quite like the cameras. For £1,000, go and buy yourself one. Then you can do it every time free of charge. But and you can muck about with them. They're really good fun. Okay. Next, what we got? Have a look at the maintenance schedules. Boring as anything in terms of it's just admin, but you do need to give pumps, fans, motors a bit of service every now and again, and it can make a big difference. So if you're very busy and you're so busy that you haven't had a chance to follow the maintenance schedule, just take a second look at that decision, dig it out, and just make sure it's being followed. Okay. This one's an interesting one. This one probably doesn't save you energy, so it's a bit of a cheat, but it will save you money. Okay, what you've got is on your electricity bill, you will pay for the electricity, the power you use. Okay, easy. However, you will also pay normally for capacity. So let's say that you give us. I'll give you a real life example. You pay us £100,000 a year, and we guarantee. I can't remember, it was about 200 amps will always be there. So when you turn your factory on, you've always got 200 amps. Okay. And that costs the electricity company because they need to make sure that whenever you turn it on, you've got your 200 amps coming through. Now, the amount of capacity that you buy is based on your peak use. Okay, so when everything's running. And sometimes you can reduce the peak use just by scheduling things at different times. Okay, so number one, and this is a real life example of a shop, a large hardware store. We were up on the roof. They've got two big chillers on the roof, both coming on at exactly the same time. Okay, and what we did is we fitted a small delay unit, so one unit comes on 5 minutes after the other. So instead of a big peak at the start, you got two baby peaks. They were able to reduce their capacity down, their capacity sort of fee to the electricity company, by about 50,000. Not pounds actually, it was New Zealand dollars, but 50,000. So it's well worth doing. And the actual device itself was, sort of about £50, £100 to fit. The other thing you can do, if you're clever about it, some things don't need to be on all the time. So if you imagine you've got a large walk-in chiller, it doesn't need to run 24/7. Sometimes you can just chill it down, let it heat, chill it down, let it heat, all within the operational sort of parameters. You might want to think about using cheap electricity at night to do the chilling. You're not going to get rid of all of it, but you can move some that maybe happened at 6 or 7 o'clock in the evening, peak time, and put that at 3 in the morning. Okay, it's called load shedding and load shifting. Okay, very, very good. This one's a good one. I saw this working in a large cafe in central London, where they had a bank of chillers on one side of the wall and some water processes on the other side of the wall. What they're able to do is go through a heat exchanger and use the ejected heat from the chillers just to pre-warm the water. It didn't get it hot enough, but it lifted it from, say, 11, 12 degrees up to about 18, 90 degrees. And that saved them an absolute fortune. Okay, so think about, it's called energy harvesting. If you've got something that kicks out heat, see if you can use it over here. Okay, what else we got? ESOS. If you are doing ESOS, if you're in the UK, where you have to do this by law, and some other countries as well, I mean, it's a European directive, you will have a walk-around energy audit. A lot of people just take those and put them in the drawer. My advice to you is have a chat to the ESOS auditor before the audit's done and say, look, we really care. Can you do a super good job? Put it in language I understand and give me examples, costs and calculations in a summary format, and that way you can get an ESOS report that makes sense for you. Okay, it will look at how old the kit is. It will look at how you use it. It will look at cost of replacement. That's good stuff if you sort of spend the time to get it. And if you're not doing ESOS, if you're overseas, then what you can do is get an energy assessor in, give them the same kind of brief. Energy assessments are normally somewhere between £1,000 and £3,000, depending on who you get and how complex the job is. Get a report, start working with it. Okay. Last one for you, fit solar. It's just a no-brainer. And I'm not really big on wind, unless you've got a really big site that can take a really big turbine, or you've got a stream running through. That'd be great if you did. But if not, get yourself some solar. If your roof can take it, or you've got some spare land, fit some solar. There's nothing like generating your own power. Okay, good. That's 12 for you. As I say, if you don't save at least 10% by doing those, every single penny you paid on this video, you get back. There you go. Thanks for watching. If you like more of this sort of stuff, subscribe or hit the bell button. And if you've got any questions, this is what I do. My passion is saving you carbon in your company. Just let me know. My contact details are on the screen. Okay, thanks a bunch. See you next time.